world where technology reigns supreme, there exists a hidden tale, a tale of thirst and ingenuity, of chips and water. Our story begins in a land where water is abundant, a vital resource that sustains life and nourishes the earth. But beneath the surface lies a secret, a hidden truth known only by a few. Three young scientists, driven by curiosity and a thirst for knowledge, embark on a journey to uncover the truth behind the intersection of groundwater and the microchips manufacturing industry. Here in the heart of innovation lies a hidden connection, an interrelation that binds the production of chips to the flow of water. But as they delve deeper, using a scientific, data-driven approach, they attempt to uncover the relationship between groundwater and microchips. The little-known tale of the thirsty chips, a tale that holds the key to a sustainable future for the generations to come. A journey that will change the way we view technology and the world around us.
So from my understanding, a semiconductor chip is a conglomerate of different electrical components such as resistors, transistors, and capacitors that are placed on top of a silicon wafer. This ends up creating like an integrated circuit, and it is essentially the backbone of all of our modern day electronics. Our smartphones, smartwatches, laptops, tablets, we want them to be smaller, we want them to be lighter, we want them to be faster. The people's wants for smaller and more efficient electronics makes the industry want to meet that need. Well, the pandemic made a recent boom because everything had to go online. People were working from home now. Some medical systems went online, and a lot of people were needing electronics. So it was like a supply-demand issue, and we have to innovate, to research and develop different ways to make these chips more advanced, more efficient. I think a major resource would be our skilled labor workforce. Another resource would be materials, needing things like rare earth metals. And of course, given the nature of the documentary, we need water too. So those are some major resources that are needed for the industry, I think, that I could think of.
What do you think are the things that you use on a daily basis that contain semiconductor chips?
Almost every piece of technology we use today has semiconductors, so our
phone, laptops, my wristwatch.
The washing machine, the refrigerator, the LED bulbs.
Pretty much anything that uses smart technology.
Even the rice cooker I use at my house that uses semiconductors. So yeah, a lot of different tech uses it.
What are the resources that you think go into making those chips?
I'm not familiar with the manufacturing process, but I'd have to guess just any sort of precious metals and water, maybe some plastic.
Also, there's manufacturing tools, so there's a whole lot of metals that go into it.
Okay. So I would say raw materials like silicon, germanium.
And of course, the ultra-pure water that needs to go into actually having the sterile environment for semiconductor chips.
Do you think water is a critical resource or an optional one?
Water would be essential, at least in my opinion.
Right now, it's definitely really critical.
It is used for cooling equipment.
The cooling aspect of the rest of the process, you definitely need water.
In terms of cleaning and cooling, it's probably one of the more available ones.
It is used for various chemical processes.
It's a critical resource.
It is definitely a critical part.
Now that you mention it, it makes sense that it's a resource in that industry. But it wouldn't be something I would think of immediately.
So much of our life is intricately linked to water. Even with our cell phone, there's some amount of water that went into producing the cell phone, and everyone has one now. How much water is used in the semiconductor manufacturing industry. What we see is that some of these plants can use upwards of a few million gallons per day. Some can use tens of millions of gallons per day, and that's quite a bit of water. We'll use a term called an acre foot. And it's a weird term, but if you envision a football field, like Purdue's football field, and you remove the end zones, if you look at that football field, what's left of it, that's about 1 acre of land. So if you flood that 1 acre of land to a depth of 1 foot of water, that's 1 acre foot of water. It's a volume. So in order to get 1 million gallons per day from the aquifer, that's equivalent to flooding that field to a depth of 3 feet. So you're pumping that amount of water from your aquifer each day if you're pumping 1 million gallons per day.
The chip manufacturing process uses 80% of the water, and much of it includes using ultra-pure water for wafer cleaning. The source of water can differ from plant to plant. However, typically, major proportion is sourced from groundwater through pumping wells, and the remainder can be supplemented from additional sources. Once all this water is circulated through the factory, the outflow is called sanitary water, which is then directed to a water treatment plant where it is treated to meet state quality standards. The return flow would be recycled or reused within the facility. The remaining would be discharged to a nearby river or stream.
In some cases, we're overdrafting storage in these aquifers. Some states do a better job of managing their groundwater resources than others. In some states, they may not have good aquifer mapping programs. When I think about here locally, some of our aquifers are understudied. One of the big things that we don't know with some of these aquifers is their spatial extent and how much is actually stored underground. Groundwater is a finite resource. The estimates vary somewhere between about 0.7, 0.8% to about 1.4%. So of all the water that's on Earth, groundwater is somewhere around 1% of the total amount of water on Earth. So it's a small fraction of what we have. The vast majority of the water on Earth is salty, it's saline.
AI uses a lot of water throughout the whole life cycle, both directly and indirectly. The direct water usage refers to the water needed to cool down data center facilities. Many of the larger AI models, such as GPT and Llama, are trained and hosted in the cloud. They use a lot of electricity. The electricity is transferred into heat. To avoid server overheating, we need cooling. And water evaporation is the most efficient way to cool down data center facilities. The indirect water usage has two parts. One is for generating electricity, the other one is for making AI chips. Making AI chips is a very water-intensive process. We need ultra-purified water for cleaning, etching, and rinsing the wafers to prevent contamination. There's not much information about how much water we need to make AI chips in the public domain. But generally, hundreds of liters of water is needed to make a single AI chip. So the semiconductor manufacturing process really contributes to a significant part of AI's overall water footprint. As the AI demand continues to grow, we expect the environmental footprint of AI to grow as well. In particular, the water needed for making AI chips. So it's really important to start looking at the sustainability practices to reduce the water usage for making AI chips.
In the pursuit of sustainable solutions, how do we strive to implement innovative practices to reduce water consumption in the microchip industry? Water utility companies work very closely with chip fabrication plants to make sure that their water use, quality or quantity-wise, is within regulations. Some states have stricter regulations than others depending on their water scarcity and water availability. The fabrication plants are allocated water quotas, which can only be accessed through water utility companies. So the water utility company is answerable on behalf of the chip fabrication plant for keeping and reporting records of their water balance sheet. Water utility companies also ensure that the discharged water meets water quality standards. Therefore, water utility companies can play a vital role in implementing best practices for water usage within the semiconductor industry.
Having hydrologists, hydrogeologists, water managers having us come to the table, being asked to join the discussion with the engineers who are leading the frontier of the semiconductor industry so that we can discuss ways to minimize the impacts on aquifers while still being able to grow the industry in ways that are environmentally sustainable.
As the AI demand continues to grow, we expect the environmental footprint of AI to grow as well. In particular, the water needed for making AI chips. So it's really important to start looking at the sustainability practices to reduce the water usage for making AI chips. It's not just about semiconductor manufacture. It's really time to start the dialogue about water sustainability for AI computing. So users should be made aware of their water footprint associated with the AI usage. At this point, users have no idea about how much water they use indirectly when they use AI products.
And I would think the general public should create some sort of awareness that would keep the industry in check.
Being aware of this problem and being aware that innovations need to happen, people could attempt to find other solutions for manufacturing.
Research and development can play a huge role in this. I think it's our job as researchers to try to come to solutions. Researching different ways, different methods to fabricate wafers or different ways to manufacture semiconductors.
We can still grow the economy, grow that industry, and hopefully minimize the impacts on these local aquifers.
Maybe sending students on internships or sending students on trips to learn this entire process from start to finish.
We could encourage, educate local communities, maybe train them how to do their own monitoring programs.
I mean, we're the 21st century. Recycling should be something that they actively do.
The leading sectors in semiconductor industry can learn from high-tech companies that have already applied successful and efficient water management systems.
And maybe reallocate some of our priorities. So instead of prioritizing economic growth or manufacturing or industrialization of every single aspect of human life, living within the means that a planet like ours can sustain.
Also, remember that there's only one Earth, right? So why not try our absolute best to take care of it with every decision we make when possible?
By harnessing the power of collaboration and innovation, we can pave the way for a more sustainable future for generations to come.
We truly understand the importance of semiconductor industry and the current technological advancements that are going on. But at the same time, we feel it is very important to talk about natural resources, especially water, which plays a key role in the functionality of such an industry.
While we're at this critical juncture in technological advancement, it would help us to take a step back and consider how things will play out along long time scales. What impact would these proposed water withdrawals have on the aquifers? While economic growth and industrial advancement depends on water security, good water management policies are crucial for their sustainability. It's important for us to have these difficult but much needed conversations sooner rather than later.
We really do hope that all the relevant parties would acknowledge the seriousness of the existing issue and will attempt to put in place proper measures, policies, and guidelines that would aid the sustainability of our groundwater resources.